Hey, welcome back to your favorite Fundamentals of College Math class. We're going to take a look at these review questions here, one by one, 1 through 16 here. Let's start out with question 1. You've got a sandbox that is a length of 10 feet. You've got a width of 5 feet. How many cubic feet does it hold if it's 2 feet tall? So if the height there is 2 feet. So in this case, we'd have 10 times 5, 50 times 2, 100. Feet times feet times feet, cubic feet. Alright, part B. How many cubic feet of sand must he purchase if he puts 7 inches of depth there in the sand? Well, the problem is, if that is 7 inches instead of 2 feet, we just fill it up to 7 inches. Alright, so 7 inches is our height. We got to convert that to feet. How many cubic feet would that be? Well, we have 10 feet by a width of 5 feet, but then we got to convert this 7 inches to feet. So for every foot, there's 12 inches. So notice our inches cancel. So we have 10 feet times 5 feet times 7/12 feet. Let's go ahead and multiply that. That'll give you 350 over 12 cubic feet, or 175 over 6 cubic feet. In other words, let's see, that'll be 29.16 repeated. Okay. Alright, number 2. Farmer's making a circular pen for a sheep. He has 288.88 meters of fencing to use. What should the diameter of the circular pen be? So here's the fencing, right? That's our circumference that we have. So circumference equals 2 pi r, but I'm going to use pi times diameter since they're asking for that diameter. So you get 288.88 meters equals pi times the diameter. So what would what's that diameter got to be, right? And notice it says use pi is 3.14, so we can go ahead and 3.14 in for diameter and divide by that. You can use the pi button too. Be a little more exact is not a bad thing. So if you use the pi button, you get 92. Let's see, if you use the pi button, you get 91.95335.992 exactly. I'm just going to round that to in this case, to the nearest whole number, but like I say, it depends on if you use pi or if you use the 3.14. Alright, number 3 here. A flat screen television is advertised as being 59 inches on its diagonal. If the TV is 18 inches tall, then how wide is the screen? Right, so we've got the diagonal of this TV they're giving us 59 inches, and then they say, well, it's 18 inches tall. Right, we've got this right triangle, so let me call that A. How wide is this thing? So we go A squared plus 18 squared equals 59 squared. Subtract 18 squared on both sides. A squared equals 3157, and we take the square root of that. Looks like we get 56.187187115, round to the nearest hundredth, which is okay. Number 4, I can ride my bike. Looks like we're doing a conversion here, 11 miles. So that's my rate in 1.5 hours. Convert this rate so we can go 11 miles per 1.5 hours. Convert this into feet per minute. Well, let's go to feet first. So there are 5,280 feet for every 1 mile. So now we're in feet per hours. And we want it in feet. Feet's fine, but we want it per minute. So let's convert these hours to minute. For every 1 hour, we have 60 minutes. Notice our hour units are gone. So now we're in feet per minute, and we just got to multiply everything. So we got 11 times 5280 times 1, so all my numerators, I get 58080, and then 1.5 times 1 times 60, looks like we got 90, and notice we're in feet per minute. So that's 645.3 repeated. That's our feet per minute on this. Alright, when ibuprofen is given for fever to children from 6 months up to 2 years, the usual dose is 5 milligrams per kilogram of body weight. When the fever is under 102, how many milligrams would be the usual dose for an 18-month-old weighing 24 pounds? So, number 1, we got to get the 24 pounds. We got to get that. Notice that the dosage is 5 milligrams per kilogram body weight, but we're in pounds. 24 pounds. So let's convert that. For every 1 kilogram, it's 2.2 pounds. Notice our pounds cancel. So 24 times 1 divided by 2.2, 10.90 repeated kilograms. Okay, that's how much the baby weighs. So since it's 10.90 repeated kilograms, now I'm going to multiply by the dosage, which is 5 milligrams per kilogram body weight. Alright, now per 1 kilogram. So notice the kilograms cancel, so we got 10.9 times 5, 10.90 repeated times 5, 54.54 milligrams of ibuprofen. So round it to the nearest milligram, so let's round that up since it's a 0.5 there, 55 milligrams. Number 6, town's population has been growing linearly. 2001, the population was 97,000. Has been growing by 2,000 per year. So part A, write an equation. So the population in the year 2001, this is like x being 0, the year. X in years is 2001. So it's 97,000 plus 2,000 for every year. Alright, so notice if x is 0, it'd take out that 2000x, that'd be gone, and we'd have 97,000. 1 year later, if I let x be 1, I'd have 2,000 times 1 plus 97,000. So in the year 2002, the next year, I would have 99,000, and so on, right? So there's our population equation, linear equation. Part B, this rate, what year will the population reach 151,000? Well, we have our equation. Population is 2,000 per year after the year 2001. When will it be 151,000? Subtract 97,000, both sides. Let's see. 54,000. Now divided by 2,000, both sides. So it looks like X ends up being 27,000. I'm sorry, 27. So 27 years later, right? Remember, X being 0 is the year 2001. So since year 0 is 2001, this is 27 years later. So it's the year 2028. That year. 27 years later. Alright, number 7 here. Find the hourly wage if the $22 starting wage is increased by 3.2% each year for 5 years. Well, this is exponential growth. So I'm going to use the balance is the principal times 1 plus r over n. Now this is only, our compounding is annually each year. N is 1 here. Okay, so it's actually using this. Since n is 1, I can write this as p1 plus r to the t. Okay. So what would the hourly wage be if you start at $22 an hour, you increase by 0.032, 3.2% for 5 years. T is our time in years. So we got 22 times 1.032 to the 5th. Let's go ahead and take 1.032 to the 5th. That gives you 1.17057, and then multiply that by 22, and you get 25.7526. Anyways, keeps going. I'm going to round that to the nearest cent. 25.75. So that's the same thing if you took 22 and multiplied it by 1.032. Took that by 1.032. Anyways, you did that 5 times, right? You get that 25.75 if it goes up by 3.2% each year, right? All right, question 8. If $10,000 is invested in an account, find the value of the investment at the end of 25 years. If the interest is 8% compounded semi-annually. All right, remember you have annually. If it's compounded annually, n would be 1. Semi-annually, that's twice a year, n would be 2. Quarterly, n would be 4 times a year. Monthly, very common as well, 12 times a year, or daily, 365 times a year, and so on. Alright, so let's do this here. We've got P, 10,000 bucks is put up front. What's the account balance if it's compound semi-annually? 0.08. 8% is our rate. That's a 0.08. Semi-annually, so twice a year. 2 is our N for 25 years. Yeah, so we've got 10, oh, it's 10,000. 1, 2, 3. 1.08. So 0.08 divided by 2 is 0.04. So 1 plus 0.04 is 1.04 to the 50th. To the 50th, that gives you 7.106683346. Then multiplied by the 10,000. And we get 71066.83. That's how much we have at the end, right? You could also do it with your financial calculator if you wanted to, right? We'll do some financial calculators here. Well, let's talk about if we did that with the financial calculator. Time value money calculator. We put in $10,000 in. This is semi-annually, twice a year. Twice a year for 25 years. 2 times 25 is 50 times at a rate of 8%. There's no payments going in. So what's our future value? 71,066.83. Same. Let's keep going here. This is a simple interest formula on this one. Oops. Get my pen out here. Simple interest, right? How much would you need to deposit in an account? So this is our simple interest formula. In order to have $7,000 in the account, that's the account balance at the end, how much are you going to put in now? What's the principal? If you earn an interest rate of 5%, 0.05 is our R, and our time is 10 years. 10 years. So I got 0.05 times 10, of course, is 0.5. So 1 plus 0.5 is 1.5 times P. Divide by 1.5. You get 46, 66.6. 6. It keeps repeating, so I'm going to round that. That's how much we got to put in up front, right? For simple interest, this is a simple interest, a little different formula, right? Simple interest is not compound interest. All right, let's do this next one here. We've got found your dream home, so we got a $380,000 home you're purchasing. You're going to put 20% down. It's a down payment, right? So in other words, you're going to put down $76,000, right, to purchase this home. So A, what's the financed amount? Well, 380,000 times 20% down is 76,000. So 380,000 minus this 76,000, that gives you the 304,000. You can also just take 380,000 and multiply by 80%. That's how much you're going to finance. Right? That's what the loan amount's going to be. Okay. Part B. Now we can use that formula. We'll punch it into the formula first. If you want to, what's the payment going to be if I finance it with those terms there? My payment is what's the loan amount? 304,000 loan amount times the interest rate. Looks like 0.039. This is compounding monthly, 12 times a year, making this payment 12 times a year as well. Divided by 1 minus 1 plus 0.039 divided by 12 to the negative. N is 12 again, monthly, and we're doing this for 30 years. Okay. So what I want to do is I want to do 0.039 divided by 12 first. That gives you 0.00325. Add the 1 to it, so I'm working from here, then adding the 1 to it, and I get 1.00325 to the, and then I'm going to take it to that negative 360. That gives me 0.319. Now I'm going to go 1 minus that number. So my entire bottom here, this whole thing on the bottom becomes 0.689043690. Anyways, keeps going. And then I do the top, the 304,000 times 0.039 all divided by 12. And I take that 988 on the top and I divide it by that former one. Again, don't cut anything short. And this payment will be 1433.87 if you round that. Okay. Now we can do that with a financial calculator as well. Come back to part C here. Let's clear this thing. So we've got a monthly. We're doing this for 30 years, 12 times a year, 30 times 12, 360. The rate is 3.9% on this loan. We're gonna take out a loan of $304,000. We're gonna figure out this payment, but we're gonna owe nothing after we've made all 360 payments. We're gonna owe nothing. So future value of the loan will be 0. What's the payment? Notice the negative on there means I'm paying this every month. I'm paying 1433.87. You see right there. Same thing. 3.87. So let's do this part. Let me get my pen again. So that's part B. So part C says, what's the total interest you paid? Well, you paid $1433.87 per month, but you made that payment 30 years, 12 times a year. We made that 360 payments. That's the total that we paid, but we got the house. In other words, we paid off this loan. The loan was $304,000. So if I multiply those two, it's 516,193.2 minus 304,000, and I got 212,193.20, and that's my total interest that I've paid on this. All right, question 11. The ball is randomly drawn from a jar. Looks like we've got 6 red, 3 white, 11 yellow balls. What's the probability? What's the probability that we draw a red? Well, probability we draw a red out. There's 6 winners out of 20 balls. So 3 out of 10. B, what's the probability you do not get a red? Well, that's 1 minus the probability that I do get a red. So 1 minus the 3 out of 10. So 10 out of 10 minus 3 out of 10, I guess 7 out of 10 on that. You can also say, well, since it's not red, it's white or yellow. So there's 14 of those total. 14 out of 20 is 7 out of 10. Part C, what's the probability drawn is that you draw a red or a yellow? Well, that's the probability to draw a red or a yellow. Probability drawn a red is 6 out of 20. Probability to draw a yellow is 11 of those out of 20. So it looks like we got 17 out of 20 is that probability there. All right, number 12 here. Spinner below spun twice. Find the probability of spinning a red. And then I don't know how you say that. Cayenne? Color? Express your answer as a fraction reduced to lowest terms. Well, that's the probability. Probability of A and B is the probability of A times the probability of B. So probability of a red, there's 3 out of 6 slots, times cayenne, there's only 1 of those out of the 6. That's your probability of rolling that color. So we've got, that's 1 out of 2 times 1 out of 6. Multiply your numerators, you get 1 out of, multiply your denominators, 12. 1 out of 12 there. 13. Now it looks like we've got a conditional probability here. What's the probability that you did not pass given did not? So what's probably did not pass given you did not do your homework? So given you did not do your homework, it looks like there's 26 total, right? I'm looking here. 26 of those total. So given you did not do the homework, what's the probability you did? You reach into the bag, right? You've got 26 of these, and 8 of them passed, 18 did not pass, right? What's the probability you grab somebody that did not pass, given that they, right? Given that they did not do their homework. So there's 18 out of 26, or 0.6923. Since we want this as a percent, 69.23%. 14. Find the mean number of t-shirts sold. So it looks like we've got total numbers here. If I add 2, 5, 3 plus 8, it looks like there's 18 total numbers here. So this mean will be 2 times there was 18 t-shirts sold. So I got 18 plus 18, in other words 18 times 2. And I got 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10. 5 of these 10s, right? 5 of those 10s. And I've got 3 of these 13s, and I've got 8 of these 4s. And so it's all divided by how many numbers do I have? I got 18 of these numbers. So it looks like I got 157 out of 18, or 8.7. Alright, 52. We got a set of exam scores are normally distributed with a mean. Looks like we've got a mean 72 and a standard deviation of 9. So 72 plus 9 plus 9 plus 9. 63 minus 9 minus 9. So remember at the 68, 90, right, 68% of the data is in there. That's why you've got 34%, 34%. 95% of the data is in there. That's where you get those other percentages shown above that. And then 99.7% of the data is within 3 standard deviations. They want this one between 63 and 99, right up there at the 3rd standard deviation. In other words, from here, 1 standard deviation below, clear up here. So I'm going to add 34 plus 34 plus 13.5 plus 2.35. So 34% again from here to there, right? We're going from 63 up to that 99 mark. (83.85%). So approximately, if I round that to the nearest tenth, 83.9% on that. Alright, this question, the one I attached in the review does have that abbreviated table, but we're just going to use that full table here for this. Weights of a certain dog breed are normally distributed with a mean of 45. So we've got a mean of 45, got a standard deviation of 4 pounds. So that would be a z of 0 standard score. So your score, z scores. So I'm going to put the z scores. Be 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, 1 below, 2 standard deviations below, 3 standard deviations below. Find the percentage of dogs that weigh less than 42 pounds. So 42 pounds, you know, it's right in here, right? So we want that percentage right there, okay? So we're going to have to find the z-score. It'll be negative point something. And then it'll tell me that percentage. But I'm going to undo that because I'm going to have to draw on this later. So part A, z equals x minus the mean all over standard deviation. Let's find the z-score. If a dog weighs 42, we've got negative 3/4. Now I'm going to pull up my z-table. Negative 0.75. Let me get my negative 0.7. So it'd be right there. 0.22663. 0.22663. So 22.663% way less. In other words, if you round it to the nearest percent, 23%. Okay, so that's saying that's right here and below, that's 23% of the dogs weigh less than 42 pounds. Again, I'm going to undo that because I'm going to draw on this. Okay. All right, let's do part B now. Part B, find the percentage dogs that weigh more than 38 pounds. Well, 38 pounds is here. If I read the table, it'll give me this percentage. But we want above it. So we'll just do 100% minus that red. So let's go ahead and find the z-score first. 38 minus 45 all over 3. So I got negative 7/3, so negative 1.75. Let's read the z-table, negative 1.75. So I'm reading on my 5s here, negative 1.7. All right, reading along here, so it looks like right there. 0.40006, 0.4006, 0.04006, or 4.006%. That's here, 4.006%. Okay, so essentially 4% of dogs would weigh less than 38 pounds, but we actually want more than, right? We want the more than 38 pounds. We want all this in black. So we're going to go 100% minus the 4.006%. So essentially 100%. I'm going to round to the nearest. So 95.994%. In other words, round to the nearest percent here, 96%. That's up here. So 96% of dogs would weigh more than 38 pounds. All right. Thanks so much for listening. I'll see you guys next time.